Good morning, everybody. We have gone a bit over time, but let's start now. I'm Reeda Iisma. I'm from the Ministry of Climate in Water Department, and today me and my dear colleague Mailis Laht from Environmental Research Center are leading this workshop. So this workshop is focusing on the implementation part of the river basin management. So all the challenges, and hopefully by the lunchtime we also have a lot of solutions. So, but as so aim of the workshop, and this workshop is divided in two parts. First, we're going to have these thematic presentations, and then we're going to have a little coffee break or pause, and then we're going to have group works. How it's going to happen, that we're going to explain after the pause when we come back. So now we start off with the presentations. I start first, giving a short overview about the river basin management in Estonia and our main challenges. Then Rob Collins from River Trust is going to give an overview about the England's catchment-based approach. And then Uldis Bethers from University of Latvia is going to introduce this water quality and quantity modeling system that they have developed for Latvia and Lithuania. So I trust that everybody here know about the river basin management plans and where the requirements come from and why we are doing it and the system behind it. Yes? I know you know, you know, you also know. So maybe to save time, I'm not going to go deep in the water management part, but concentrate more on the challenges. As you know, we all have the aim to protect water, to achieve and maintain the good status of our water bodies. The framework or whole frame how to do it comes from the Water Frame Directive, which we have adopted to Estonian Water Act. And I think it's at the moment very important thing is that not does it only give these guidelines or frames how to manage the waters, but it also gives the deadline, like by 2027 we already have to achieve the objectives. So, and it's like happening tomorrow. So in Estonia we have divided waters into 744 surface water bodies and 31 groundwater body units. And these are the management units, and I trust that you all know that not all waters are water bodies as management units in the river basin management context. So, like everybody, we also have done our river basin management plans and program of measures for 6-year periods. Our third period river basin management plans were authorized in the end of 2022, and we actually have Kadri Normak here, who is responsible a big part from it as a consult. What? Yes, and as you know, we have to draw up the river basin management plans for each river basin district. In Estonia, we have 3 river basin districts. There's Western Estonia River Basin District, which is the largest. Then we have East Estonia River Basin District, on which the northern part is covered with this CleanEST project. And then we have down here in the corner, we have Koiva River Basin District that we share with Latvia, and actually majority of the river basin actually lays in Latvia territory. So you all know this graph, how we assess the status of water bodies. Yes, we do it the same way in Estonia as for the other member states. The data from year 2021, we had achieved the good status of 52% of the surface water bodies and 76% of the groundwater bodies. But with the groundwater bodies, maybe as looking at the achieving the objectives, as some of the water bodies are in good status, but in risk, or then the maybe more correct percent is actually 36%. I have here a link also in the presentation to our interactive map, online map for the illustrating the water body statuses, but I'm not going to show it to you. You can look it later, because we're a bit tight scheduled at the moment. So these are our main pressures. Of course, the diffuse loads from agriculture, it's main pressure, significant pressure both for groundwater and surface waters, and also other pollutants like hazardous substances is important pressure both surface and groundwater. Then for groundwater, also dams and the maintenance of the melioration systems is important or significant pressure. And for groundwater is also the abstraction of water. So how we plan the measures? The basic information came from this basic analysis that like the analysis of pressures and impacts, the characterization of the river basin district, the economic analysis of water use, etc. We map the pressures, we assess the statuses, we connect the pressures to the quality elements that are failing the good status, and then we plan the measures. It's basically like that. And as you know, then the measures are divided into basic measures and supplementary measures. Basic measures are the ones that we have in our legislation, and they are compulsory because they are in our legislation. And then the supplementary measures are the kinds that are like voluntary. We plan them in addition to these basic measures when the basic measures are not enough to achieve a good or to maintain a good status of water bodies. So in our program of measures, we have all sorts of measures, all in 2,425 measures in the program of measures, and the total cost of our program of measures is 854 million euros. And the financial gap is 165 million euros that we're lacking, so quite a lot. So these are the main implementers, have divided them into three sectors. There's public sector, and 62% of the measures that we have planned in the program of measures are directed to the public sector. Then 30% of the measures is for private sector, and then for individuals like landowners or dam owners or general public, there's 8% of measures. So here's the distribution of the responsibilities in Estonia. The Ministry of yes, it's environment, but now it's Ministry of Climate. We're setting the goals, drawing up the river basin management plans, doing the overall general coordination, the updating the plans and implementation of the plans. Then we have environmental agency who does the monitoring, status assessment, reporting to the European Commission. Then we have this kind of like a supervisory body, Water Management Commission, that is under Ministry of Climate. And there's this from different organizations, the stakeholders are gathered, and they are like supervising or following the whole procedures and like approving the decisions or something like that. So then we have an environmental board whose responsibility is organizing public involvement and coordination of the implementation of program of measures, and also the environmental awareness raising. So, and our main challenges. I think it all starts from the lack of political interest and support. And it results in lack of resources to implement the measures, to create the administrative capability to nudge or force the implementation of our measures, also to develop all the necessary tools for implementing or coordinating the implementation of a program of measures. And also the problematic is inability or lack of will to set priorities. So, but as you heard our Vice Chancellor yesterday, Kaupo, he said that we can't talk only about the problems, but we also have to offer solutions, at least 3. So here's some solutions. Actually, when we were updating the river basin management plans and drawing up the program of measures, then we mapped all these problems we have, and we have planned these measures or actions in the program of measures, like what we should do to solve the problems. But of course, the implementation part, it might get stuck because we don't have enough resources. So, a lot of this implementation of river basin management plans, as there is a lack of political interest or support and lack of resources, then all our officials, big part of our job is to find external resources, allocate external resources. So for this, we also, like for West Estonia River Basin Management Plan, we are applying life SIP, strategic integrated project funding for next 10 years. So, and with the project, we would like to solve the administrative capability and tools problem, at least, and also a bit this political interest part also. Then another challenge is insufficient integration of different fields. It's something that we want to focus now when we're start to prepare the 4th period river basin management plans. We have planned a study to harmonize the objectives and measures of different directives, so it would have a synergic effect. And we also have measures in our current 3rd period river basin management plan for changing some paragraphs in the legislation acts to make the to resolve the conflict parts or try to make it more easy to solve or more understandable. So, because there are a lot of conflicts, like water protection versus nature protection versus social expectations or economy or cultural heritage. Like, you may think that the water protection and nature protection are the same, but not necessarily. So then there's low awareness and implementation capability among our implementers. It's basically among the private sector and individuals. I think it's a bigger problem because our river basin management implementation for previous 2 cycles, we have been focusing on the public sector. Public sector knows what they have to do. They know what the river basin management plan is, they know the measures, and they are implementing the measures. Like it's working for public sector. Maybe there are some bumps regarding the local municipalities, because the stuff is changing and you have to explain it over and over again, but the amount of local municipalities is quite small, and you can manage it to raise their awareness with the resources that we have at the moment. So, but the private sector implementers group, it's really big, like tens of thousands of people, and there's one part is that the general environmental awareness is low, but also the knowledge about the river basin management plans, it's like almost non-existent, which results in that they're not implementing the measures. Of course, there's lack of resources, which might be that we might have planned disproportionate measures because the level of assessment of effectiveness or cost effectiveness is not that good yet, but we're planning to improve that. And lack of knowledge of skills to implement the measures, what are the technical possibilities, and maybe for individuals, it's also problematic to deal with all the administrative actions, like if you need some sort of permit or registration, the environmental board seems like really scary place, like where to go. So, but we are dealing with these challenges, like we have Environmental Investment Center providing the financial support for the implementing the measures, and the financing for the environmental program, it's connected with the objectives of river basin management plans. Then we have an Environmental Board and State Forest Management Center who have programs for raising awareness, and we are increasing the focus on water issues. We also support the citizen science project, also in our LifeSIP wetlands project that we are now applying. We have planned citizen science activities. And of course, allocating external resources for creating the implementation coordination system, that we would actually have competent people who could reach out to the implementers and to support them, explain them what are the expectations, what they have to do, things like that. Today we don't have people for that and resources to create such a team. And then there's the data concerns. In some cases, there's too little data. Like we have 140 investigative monitoring cases for this third river basin management period. The data is scattered in different databases, all reports, research reports or studies, There's also some data that's in poor quality or is technically difficult to access, and it all makes very difficult to plan the measures or manage a single water body. You have to gather the information from so many different places. It's very time consuming, and the person who does it, he or she has to know where to get the information. So, but again, we're looking for the external resources to improve that part. Also in this LifeSIP project, we have planned this digital, developing the digital tools for the implementation coordination system. So thank you. That's all from me. And now, do you have any questions? Yes. So one moment, please use the microphone. Then we also have Zoom participants, so they will hear you too.
So you said that groundwater bodies is 76% good quality. So yes. 24 is not good quality. So where is the pressures?
It's water abstraction is and the chemical status. Yes. I mean, two bodies are due to the abstraction here in the eastern part of Estonia, and the others are yes, and we actually have lowered the objectives for 2 groundwater bodies regarding the chemical and quantitative status. They are in the eastern part of Estonia.
And the chemical status, so what you found there?
I'm not competent enough to answer that question, but Mailis is.
I think this is mainly the residual pollution from the Soviet times, oils from military and also from the oil shale mining activities. So that's are the in chemical side, and they are complex. They are not like one substance. They are really like complex pollutions there. So.
Yeah. Okay. Any other questions? No. Then I give the word to Rob. Yes. So you can use it back and forth.
Perfect.
Yes.
Yeah, good morning to everyone. So I think I saw most of you yesterday. I'm Rob Collins. I work for an environmental charity in the UK called the Rivers Trust. And we have around 60 individual rivers trusts around the country. They work to restore and protect the freshwater ecosystem through catchment management. And for 10 years or so now, magical. For 10 years or so now, we have this initiative in the UK called the Catchment-Based Approach, CABA for short, and it's all about driving collaborative water management, so trying to work with all sectors of society around water and land management. And it came about really 10 years ago from our central government, because under the Water Framework Directive, you know, there's this article around public participation. And back 10 years ago, our government was doing no public participation, and there was a legal challenge. And they said, okay, so let's address this through this catchment-based approach and try and establish a more bottom-up, community-based way of working as well. Just to make you feel a little bit better, we have not a single river in England in good chemical status, so 0. mainly due to 3 legacy chemicals that have now banned, but still they're there. And I think ecological status is something like 14% good status, so yeah. Anyway, so this initiative, catchment-based approach, so 10 years now we've had established just over 100 river catchment partnerships. You can see them on the map here, covering the whole of England. It's England and it's cross-border with Wales and Scotland, but primarily England. And each of these partnerships has a mix of private, public, civil society. So let's say the good ones have 2 or 3 environmental NGOs. It has its own life. And with local, with local government and some businesses, local farmer groups, community groups. Of course, with 106 of anything, there's some good ones, some not so good ones, some in the middle. So it's an interesting initiative. And each year we ask them to report on their activities, really. So what have they been doing? Who is a member of their partnership? Who do they work with? What kind of projects they do? How much additional funding they can create, because they receive around 15,000 euros each from central government each year. So it's not so much money, but they also manage to secure, let's say, between 2 and 3 times this amount from non-government sources. So government always likes to hear this figure, that their money is being multiplied. The initiative comes with we have a national support group to support all the partnerships, and we have all the organizations involved on there. So that group works to identify like opportunities and barriers to working and so on. And also it runs some thematic groups, some working groups on like urban water management or floods or agriculture, things, particular issues. And also interesting Reeda's point about the business, because we have also a very small water stewardship team, like 3 people who work with businesses. That could be big business or local business, but the aim is to try and help businesses understand exactly the point you're making better. Maybe they don't care about the details of the Water Framework Directive, but they may feel like a reputational risk or regulatory risk, something like this, and they want to be involved in some way. So we try and encourage that. So some examples of the kind of work, most of the catchment partnerships, they work with farmers in some way to typically address pollution from agriculture. Not always, but mainly. And so things like wetlands and cover crops and silt traps to prevent, sediment and phosphorus and so on. And also just to help the farmers, I think, to run the farm more sustainably, improve soil management and so on. And interestingly, this point here about the supply chain, we have 4 or 5 examples where big companies are involved. In this case, these photos are from work in the east of England where Coca-Cola are involved because they buy nearly all the sugar beet for their drinks. And they became interested, I think, more for reputational risk, because there's a lot of sediment and phosphorus that comes off this land, and the sugar beet farmers could improve. And so they've become involved in this particular catchment partnership with they fund some of these measures. So it's that relationship. So again, whether they really necessarily understand the details of the Water Framework Directive, I don't know, but more they understand the reputational risk to them, and they should be seen as being good managers of the land. Then a very common thing, nature-based solutions, both in the rural and urban environment. So it could be for flooding, it could be wetlands or buffer strips for water quality. Yeah, we've done some work to try and optimize where these should be located in the catchment as well. And again, some small interest from private investors sometimes around maybe carbon or recovering nature, just beginning to emerge. And then another nice example, this is a particular catchment in northwest England, and they're quite strong on tackling invasive species. So they've mapped the species everywhere along the river corridor, and they have a nice plan of action to try and control or remove and so on. So it's something that you kind of have to do at a river catchment scale and get a number of different stakeholders involved. And then the whole thing has a lot of data and evidence alongside it. So we developed this data package, and it has 200 different data layers that are freely available to anyone in the partnerships. And you can cut it at river catchment scale or county administrative scale. So it has things like flood risk, water quality, where to target nature-based solutions, and outputs of some models as well. So this is from a model that predicts sediment, risk of sediment runoff in rural land on the right there. So there's a lot of data. You could argue maybe not enough. We need to give more guidance, because a lot of the partnerships don't necessarily know what to do with the data exactly. But at least it's there, and each of the partnerships, they've developed a catchment plan as well. So all 106, but again, some have very good plans, like this one here. I put the link on this one, Eden in the northwest of England. It's over 100 pages long, but at the other end of the spectrum, you get some plans that you can only just call them a plan. So it's varied quality. But this is interesting now in discussions with government, because all along for the last 10 years, the government, they created this, and then they've struggled to understand how this should feed into the river basin management plans. So one, in the second cycle, each partnership had its own page in the river basin management plan. So they had a link to their catchment plan and some of the work that they had done and so on. So that was nice to see this, and now the discussion we have with government is, okay, how can we make this more integrated? How can these partnerships play a stronger role? And still we're waiting to hear exactly. But it could be that government is about to give them more money, because we said, okay, 15,000 euros, you can do something, but if you really want to make a big difference, they need more money. And then some of them, I don't know if you remember in the presentation from Laura yesterday from the European Environment Agency, she mentioned story maps, and some of the partnerships, not all, maybe 30, they developed some nice looking story maps and online platforms for really communication. So just to highlight them as a partnership and what they do and some of the issues. So this is quite a nice development. And then the final element, I guess, they're generally quite strong, the partnerships of the community engagement and offering volunteering and citizen science. So things like this is in London, community engagement with sort of planting up the riparian zone and improving the habitat of the river. And then this is a nice one on the left here, a guide to looking at, they call it outfall safari, but it's kind of storm overflows and outfalls that can be polluting, and how to identify them, and without measuring anything directly, just to try and describe them and survey them. And we produce some guidance for other citizen science. What can you do? What kind of field equipment do you need, and so on. And then also some community schemes around SUD, sustainable urban drainage. Just a very small scheme here of digging up the concrete and putting in some mulch and some flowers, but similar things working with schools as well in some cases. And then interestingly, there's one or two techniques in the UK that this one called Riverfly looks at river health through monitoring of invertebrates in the river. And so it was started 10 years ago, but now actually our environment agency use it. So it tells you more or less the health of the river, but it also has like a threshold. So if the numbers come down below a certain threshold, then our environment agency, they get involved and try and identify the source of the problem or pollution. And there's 2 or 3 nice examples where they found 1-2 years ago, I don't know why, but a huge amount of pesticide coming through a wastewater treatment plant and was picked up through this monitoring. So it's kind of nice. It's easy to say citizen science is good, but often it can lead to nothing. But in 1 or 2 cases, actually, it's triggering some action, so it's good. And then just finally, we're involved in a big attempt to, with water companies, to try and push citizen science and community monitoring to another level to get it harmonized and accepted using certain methodologies that our government and the Environment Agency in particular will begin to accept. So, interesting challenge. And that's it, really. So I guess things have evolved very slowly over 10 years. There's some nice examples, really good examples of collaborative water management, but it needs time to get going, and money and a lot of support, I think. And still we're working out, and government, I think it's taken them 10 years to realize actually this thing they created, now they're beginning to think actually it could be really useful. We could really put some more money in and the plans could help us, and let's see, over the next year we could see a big change, but that's to be decided. And I think, anyway, several elements of this approach could be, you know, applicable anywhere, really. So, that's it.
Thank you. Do you have any questions to Rob?
Okay, you mentioned that your government actually initiated that and now is willing to give more resources or money to that. How did you manage that? Because usually in our case, always everything is cutting like down, nothing is coming. So what was the trick there?
One reason is because money is coming down for our environment agency. So they halved how much water quality monitoring they do over the last 10 years. So maybe a slightly cynical answer is that as they cut the environment agency, they're beginning to think, okay, we cut it too much, and now we like this idea of wider collaboration, so we'll push the money this way. Maybe. We haven't seen an increase in money yet, but maybe. So, and also I suppose, when we talk to them, they can see the benefits of this, that actually, you know, early in my career, when you won some money, it was for your organization for one issue, and that was it. Whereas now, most funding organizations, including the government, they want to see some kind of collaboration, some kind of bigger, more holistic project. So what we keep saying to government is, if you stop this now, you're only going to have to reinvent it in some other way, some close. Collaborative water management is a thing. It's not going to go away. So, and then also a new development for us is the government released they call a plan for water back in May, and they included reference to the catchment-based approach and the catchment plans. So now they have to do something. Almost they have to do something. So I don't know if there's an easy answer, but for 10 years we kept telling them, keep saying to them, this is a good thing. You don't give it enough money, but it can be a really good thing if you give it enough money. And one thing I think really helped is this reporting, what I said we asked the partnerships to provide. Even though it's a little bit voluntarily done, it really helps us to be able to say, okay, each year we know these partnerships are doing this and these partnerships are doing this. Otherwise, we can't talk to 106 of them. So we give them a survey. And then the figure that the finance people in government always like is, okay, this 2 or 3 to 1 ratio, so they get 15,000 euros and they turn it into 45,000, something like this. And so government likes this. It's simple, simple money, non-government. And so this immediately, okay, this sounds good too. So this has been really important, this reporting, I think, and has meant that they kept on giving the money. Yeah. But now we said to them recently, you need to decide. It's no point just continuing like this. You have a chance to make it grow big. So let's see. I don't know.
Yeah. Thank you, Rob. And our final presenter is Uldis Bethers from University of Latvia. Was it yes?
Hopefully this works and it goes forth and back, and there is laser pointer which is useless on this screen. Okay. So my name is Uldis, I'm from Latvia, my background is physics, and and I'm mainly in modeling things, so maybe you can raise your hands how many people are being in touch with water quantity and quality modeling. Okay, super. Then there are plenty of you. And okay, I will speak about one particular modeling system, which is soil water assessment tool. It's American software, but like in car industry, it's just engine, yeah? And you have to build everything by yourself around this engine. And I will go through 6 points. Let's see how fast I will do it, but let's see. First will be quick, why and when it was developed. Then second, what are the components of a modeling system. Then I will stop for quite a large part of this presentation on the input data and model setups. And then go to some modeling frame, our approach to calibration validation, and also show some results and post-processing, what can you do with it. The background, we started it roughly 10 years ago when there was a guy in Lithuanian Environmental Protection Agency who has he still has a vision that models may help with river basin management plans to quantify measures and assess ungouged places and so on. And he was a big fan of soil water assessment tool because of his background, and he persuaded his bosses to develop a soil water assessment tool model for Lithuania. When we were successful in doing this, few years later, he decided that the system is mature enough to do to base some part of river basin management plans on SWAT model results. And in recent, it was second step. And in recent years, there is integrated life project called Good Water. It's twin project in Latvia. Probably you exchange experience with Estonia, and we started to do the same for Latvia. And now already moved also this modeling system from SWAT to SWAT Plus because Americans decided to do so in their software, which is still some Fortran code from 80s, 90s. Yeah, okay. It's a timeline, and then the components of this water quality modeling system, of course, is input data, which have to be pre-processed, harmonized, or gathered from various sources, and then put in some way that model can use them. Then this data is plenty, so you have to have a data storage system with some database versioning. Then there is the modeling engine itself, it's SWAT Plus in our case. Then all this data, model results, model runs have to be handled somehow, so there is a system of scripts which actually then is the task of modeler to develop these scripts and execute runs, scenarios, and so on. And when you get a bunch of data or very much of data and you have to post-process it somehow, so where you have to develop your own tools, because usually these modeling systems don't have that. Yeah, so these are the components. So I will go through the data. Data is simple, it's elsewhere the same. It's terrain. Terrain is available nowadays on few meters grid. We harmonized everything to 5 meters to cells to have this raster. Then there is some land use data required. Land use data is a bit tricky because if you go for agricultural measures or impact of agriculture, you have to differentiate between various crops, which is each of them have their own plant management practice, and so there are quite a lot of them. If you can see this table with some abbreviations, it's done on roughly the same grid. In Latvia, and the number of different land use classes is around 50, yeah, you can say, when it's more or less enough, including the crops. Then you have to go for some soils. Soils is even more tricky because each of our countries in Europe think that their soils are something unique, and each of countries has their own classification of soils. And I think that in the world there is a big problem to harmonize this data, but okay. When you have these thousands of different soils which are so unique in particular country, you can come up with some aggregation of them depending on local experts. So in Latvia we end up with 50, and in Lithuania close to 80 soil classes. Of course, one thing is that everybody wants to be very original, but when you ask about the parameters of these soils, then it's clear that soil scientists not always know these parameters, especially those parameters which are important for water quality in the end of the day. Anyway, it's soil maps. You see that in Latvia there is not that good raster. Sometimes we have bigger parts uncovered. Yeah, okay, let's move further. Then the next step is river network, which more or less is fine because thanks to river basin management plans and different databases, when you do with model setups based on that, usually you have to delineate the watersheds and catchments and then aggregate them in watersheds. Actually, we came up with roughly 180 watersheds in Latvia and 100 watersheds in Lithuania. And because Lithuania is a little bit older model, computers become better. And catchment is the smallest part of a model for which you can get results. And of course, there are much more catchments than these water bodies. And this model, I show it both for Lithuania and Latvia. It's also, they work also separately, just exchanging data on the administrative border of countries. It's built up of roughly 500,000 hydrological response units, and this 500,000, these are parts of a model to which you can change. You can, and these hydrological response units are different combinations of land use, soil, and surface slope in particular catchment. So it means that if you divide this 5,100 hydrological response units to number of catchments, which is roughly 5,000, it means that in one catchment you have roughly 100 different combinations of soil, land use, and slope. Yeah, okay, let's move further. When you make these model setups, which are shown here, there are also some transboundary things for Lithuania. From Lithuania, water is flowing out. In Latvia, it's mainly flowing in, even from Estonia, not only from Russia, Belarus, and Lithuania. And yeah, that's it. Let's move further. There are a bunch of other data outside this geospatial data I mentioned before. One, it's regarding transboundary flows. You have to resolve this issue. Then you have to do something with fertilization model. When and how to apply mineral and mineral fertilizers and manure. It depends also on how far you want to move manure, if you know where your cattle is living, and so on. And this statistics, of course, is on the different spatial scale as, for instance, terrain. Yeah? Usually, cattle is known in some administrative division, depending on your statistics and so on. Then you have to go to agricultural scientists and speak about the agricultural practice to build your plant management model for each of your crops, and even if you have aggregated your crops, then probably your task is a little bit more complicated. Easier thing is atmospheric deposition, where is European data. And then you have to have meteorological observations, which also have to be gridded to resolve your catchments, at least catchments, yeah? Which is not an easy task given the absence of a dense observational network. Yeah, okay, now I move further to modeling frame. You need some tools. You have a lot of data. You have to use some database. In the course of history of this model, we have migrated from ArcGIS to Postgres database. We use SVN versioning system to keep track of various versions of all this stuff. When we got nasty surprise that in the transition from SWAT to SWAT Plus, old software development dinosaurs are slightly leaving the stage, and young people are not that good in Fortran coding, so we found more than 100 errors. So SWAT Plus is at the moment a little bit hard to use. We fixed this for our branch of this software, and then when we write plenty of Python scripts to handle the data, execute the runs, and extract the results. And then for post-processing, we use QuantumGIS, or QGIS now, and have written our own visualization tool for time series. So let's move further. Then the next step, as usually, it's calibration and validation, but please keep in mind that our goal was not to do science. Our goal was to use this modeling system as a tool for producing some water quality management solutions, or evaluate different measures. And when our approach to calibration and validation was, at first we made regionalization based on some probably local or national experience, how to divide your country into regions. When we did calibration in particular, and also, for instance, soil and slope clearly distinguish different regions in Lithuania. When we calibrate for one or few stations in particular region, based on Nash-Sutcliffe efficiency or P-bias, which actually means how good is your total amount of substance which comes out of a catchment and how well it correlates with measured time series. We did it for discharge and nitrogen and phosphorus concentrations, by the way, not for fluxes, because concentrations is a little bit more challenging, and yeah, client wanted this as well. When we transfer the coefficients of the model to all region, and then call the next step of exercise, next calculation run a validation. And then if our calibration and validation criteria is met, when we say okay, we are good with the model, yeah, and move for scenario calculation. Regarding observation data, I show you a map for Latvia. Where are these stations with different monitoring strategy, and the larger we circle, the more measurements are done for nitrate, nitrogen, I think, yeah. And colors mean higher, lower values, yeah, on our river network. Okay, I also show some good examples of calibration. For instance, on the left-hand side, there is discharge nitrates and phosphates for one particular river, where one color corresponds to observations, averaged over months, and other for model results. Of course, this is aggregated to the months. On this left-hand side, for instance, for Latvia, it's transboundary river, where both modeling systems are in work. For Barta River, it comes from Lithuania, enters Baltic Sea near Liepāja. There is also some, of course, some comparison with daily observation of concentrations, and then the lower picture is the monthly values with higher winter nitrate concentrations, of course. So, and then at the end of the day, you can see the overall validation success. It's for water quantity or discharge is upper, and the lower is this criteria according to nitrogen. And yeah, red dots are those points where there is no success in validation, where the model fails. But if the blue dots on the upper screen and these green dots dominate, we say that model is useful and we can go ahead. Don't bothering very much on particular place where you don't know what the heck is with observations usually, or some other data are wrong, for instance, regarding the land use. So we have a model on the country scale. Here you see the, now I will go to the results section and the use of the results. And just as illustrations, you see that it's in-stream nitrate concentration, which of course is higher in agricultural areas, in the lowlands, in the middle of Latvia and Lithuania. And they are lower both in sand, there are sandy soils in Lithuania or in the region which is less economically developed in Latvia, which is eastern region, by the way. It's in-stream values. Then there are also some secondary outputs from the model, for instance, crop yield in the agricultural territories. Yeah, in tons of this crop per year from 1 hectare. which might be of own interest. When there are possibilities to use the model results in source apportionment, you can track the sources of the nutrients as, for instance, I will show it for Lithuania, as transboundary or agricultural or urban, I mean point sources or natural background. I think I can do like this. No, it doesn't work. So yellow is agricultural, black is point sources. In Lithuania you see, especially for phosphorus on the left, you can see that it's downstream the big towns, and there are two big rivers entering from Belarus. One is Nemunas, entering from south, and another is Neris, entering from east. And this magenta is transboundary pollution, which can be tracked down almost to the sea. Yeah, and then the last point I wanted to include in this presentation is the use of a model in optimization of water quality improvement measures. In this case, you have to construct your list of different measures, which usually are words and come either from politicians or from environmental agencies or whatever. When you have to ask somebody, economist or some, to assign a price tag to this, to make an optimization. As you see, there are some measures which have negative cost, so probably you would like to implement this measure. And when you have to translate these measures into model language to change agricultural practice and somehow to apply this. And when it's done, you can run the multiple runs. In our case, we used generic two-factor optimization. One is how big is the improvement in our target function, which in our case was nitrate concentration, which had a target in Lithuania. They set it, I think, 2.3 milligrams per liter. I don't know, maybe it's European target. And another is if you manage to reach this target, then which set of measures is the cheapest. Here are some examples of implementation of this optimization. At first, it's the present state of nitrate concentrations. It's again in-stream concentrations, but the colors, but the catchments are colored in this in-stream color. Yeah? And this on the bottom left, it's the best you can achieve. So it means there are some parts where you cannot achieve this value. This 2.3 is yellow and greener. Orange and red is already are places where you cannot achieve this. Here are the set of optimum measures which are implemented in different catchments and are the best for them. There are plenty of these best measures. Of course, they are implemented on the hydrological response unit or on the field level, and they combine, I think, almost everything. And one of them was no plough technology in plant management. I don't know what it is. I think you don't make this autumn ploughing. Then there are some catch crops, plant cover in winter, and if all other fails, then you have to convert your fertile lands into some woodland. And be happy. Okay, thank you for attention.
Thank you very much, Uldis. Do you have any questions for him?
What can you then do with the measures that are offered in the last slide that you had there?
What we did?
Yeah, what you did.
Oh.
Like, do you actually like take these and go with them?
We speak with politicians.
Yeah.
I don't know. Probably they read newspapers or whatever. I don't know what. They came with, or maybe it's not politicians anymore. I think it's agricultural scientist already. He said that these are good measures, and they have written them already in one river basin management plan, or are going to rewrite them in another. Okay, then we sit down with some agronomist, I think it's a correct name, yeah, and try to translate it into plant management practice. When and what differs, and also with economists, with whom we tried to discuss how much it may cost. And when we run optimization scheme, which requires a lecture itself, but
we don't have time for that.
Yeah, and I don't have this PowerPoint when I have to run for my computer. Yeah, that's it. And come up with with these two figures. These are results, very general results, which are for managers already. It's the best you can achieve by all the measures you have provided to us, because we did not generate any measure. And yeah, okay. But you cannot achieve better status than here. So something will be left. Okay, then you have to do something drastic. Of course, if you dig parallel river, then your basic river will be pristine and probably also dry. But it will be good status. And then in your ditch you will have many of fertilizers. And then it's a map of optimal measures, and I think that it's more magenta when you will go for more costly measures. Yeah? Here probably some simpler measures are possible and you achieve this stuff. I think you will have this presentation. I'm sorry for the small...
So presentations will be shared with participants.
I think all these magenta is catch crops and planting winter crops and reduced fertilization, which is hard to... Yeah, all magenta stuff is a little bit related to... But I think people are doing this because they get paid by government. So it has a present.
Do you have any other questions?
Thank you. Really very interesting. I have two quick questions. Do you know, of all these measures, which ones will go into the River Basin Management Plan?
I don't know.
No. It's like almost a political decision, I guess, to say.
No. But it's not for modeler to decide.
No, I understand. But I wondered if, how much will be taken. The other question I had was on the cost. It's nice, this table. Did anyone account for the benefits of some of these measures? For example, if the farmer is putting on fertilizer in a high-risk area, there must be some cost saving as well.
This part was included in this price tag. Okay. If you have direct effect, but the function which we were optimizing first was this threshold value of 2.3 milligrams per liter for nitrates. So there was no monetary value assigned for the difference between the achieved value and this 2.3. So there was this this Inca is very nature capitalization is very actual thing in Europe at the moment. It was not accounted here.
Thank you very much for Uldis. And now we're going to take a short break for 10 minutes, and let's gather back here in 12:40 then. Yes, and then we will start with the group works.
Explaining how this work will continue. Here are standing our question leaders, Mari, Reeda, Mailis, and Elina. Sorry. And we have actually here now 4 questions for you. You can answer all of them and give some good ideas how to solve our management plan those challenges. And this will be in this World Cafe format that the question leaders will go around, and you will sit in a table, and the question will then change in 10 minutes. So should we a bit move people around, or approximately the same number in all the groups? So
I think we will divide you in different positions on the let's count because the online group is number 1. Let's count from number 2. So I mean you are number 2, number 3, number 4.
Hendrik, 3. Kolmeks loe.
3. Because online is 1 for day. Okay, sorry.
Number 2, number 3, number 4, number 2, number 3, number 4, number 2, 3, 4, 2, 3, 4.
So this is the only time you have to move, so otherwise the leaders will move. So
only the head of the groups will move it. So
yeah, and now you have those first questions already in the table. But we have actually, as I said, 4 topics. One is awareness raising of the politicians. Second one is how to prioritize the measures that we have in our river basin management plans. Third one is how to motivate the implementers. And fourth one is digital toolbox and solution for how to better implement the measures. So, but the more detailed information will be given by the question leader, so you will have the more detailed information about that. And be open, think about more out of the box, and use all the good ideas that you have heard here yesterday and today, and come up with some new ones. So let's start.